Hello everyone, today we are going to learn a DC series motor relation, which is speed vs armature current, which is IA. In series DC motor, a series armature winding which is connected with a field winding in series connections, which is shown in a diagram. If you want to study the relation of speed vs IA armature current, then we have to choose an equation which shows a relation of speed with IA, means armature current, which we have already learned in earlier video lectures, which is N directly proportional to EB over flux. It means speed directly proportional to the back EMF, which is EA of a armature, and inversely proportional to a flux which is producing by a field winding. Therefore, EB we already have learned from the relation EB is equals to VT minus IA and RA. We can replace EB by EB in the following equation, which is N directly proportional to VT minus IA RA upon flux. But here is another change. When we apply KVL in a given circuit of a DC series motor, then we have observed another resistance, which is here resistance of field, and the current is same, which is IA. Therefore, we can add here another voltage which is appearing across RF, which is IA RF, and the complete relation appears by the following relation. Here we got N directly proportional to VT minus IA RA plus RF and divided by flux. When a load increases, when a load of any DC motor increases, then IA of a motor current of an armature also increases, and the very relation will be used here like that. If IA of an equation is increasing, then the very equation of IA bracket RA plus RF also increases, and when IA increases, the volt term, which is VT minus IA bracket RA plus RF decreases. It means the very numerator will decreases because of IA increases, and along with that we know that the flux of a circuit, which is here, is depending on a IF, which is IA. It means IF and IA are same. When IA increases, it means flux of a circuit, means field winding, which is field winding, which is making a flux. The flux will also increases. It means speed, which also decreases because of increment in a flux. Therefore, the relation is that speed is directly proportional to the very relation and inversely proportional to flux. It means in a DC series motor, not only IA is causing to decrease speed, but flux is also causing to decrease speed of a motor. But keep in mind, the flex of a DC series motor will not remain constant. It will change or reach to its saturation position, or may it decrease. Therefore, at the start, if we check or study the graph between N speed of and I, therefore at the initial level till that point, from here to that point, not only IA is decreasing the speed of a motor, but also flux is causing a decrement in a DC motor speed. And after that point, this DC motor's field flux become a constant or reached at saturation position, then it becomes like that. Because here, from here to that point, only IA means current of an armature is causing a decrement in speed of a DC motor. Thanks for watching.